Hi everyone, welcome back to Java Techie. I'll dive right into the next part of our Spring Boot interview question and answer series. That's right, you can consider this as a part 2 video of the series. In case if you missed the part 1 video, don't worry, you can catch up right after watching this video and I will share the link in video description for your reference. Okay, so without any further delay, let's get started with our part 2 right now. So before I jump into the content, I want to express my gratitude for your incredible support, your engagement, likes and comment, which means the world to me, and I am here to provide you with the best content possible. So keep learning and keep sharing with others. So let's circle back to the content. So here begin with our first question, that is, can you explain the purpose of stereotype annotations in the Spring framework? First of all, stereotype annotations are used to indicate the role or purpose of a class within the Spring application, and there are different type of stereotype annotation is available like @component, @service, @repository and @controller and REST controller. So let me demonstrate all the stereotype annotations and their purpose by walk you through the code. Let's go to the IntelliJ IDEA. Now let me open any class. Let me go to the main class. So here let me type all the stereotype annotation @component, @service, @repository, then @controller, or even you can use @REST controller. So these are the 5 stereotype annotation available in Spring Framework to just define the role of your class, what your class is doing. Someone can easily identify by seeing this stereotype annotation. Okay. Now we might wondering why there are multiple annotation to just define the role of your class. So if you open the source code of this @component, this component is the parent stereotype annotation. Okay, so this is the parent stereotype annotation. Now if you will open other annotation, let's say service, this is inherited from @component. You can see here, right? Component.class. Similarly, if you will open the repository, this is also inherited from component. Now if you will check the other one, I mean controller, this is also inherited from @component. Now the next part, if you will open the REST controller, it is not directly inherited from the component, but it inherited from the controller class. So if you will go inside this controller, again the controller is inherited from component. Okay, so this is what you need to remember. Component is the parent interface, service, repository, controller and REST controller are child interface of the base, which is component. And now we are these many annotations to just define the role of our class. For example, so I have a controller class here, demo controller. Let me expand it. I have also service, even I have also repository. Okay, now see here in the controller class I have annotated @REST controller. Similarly in the repository I have annotated @repository, and in service class I have annotated @service. Now by seeing this annotation, some developer, whether he is experienced or fresher, he can easily identify, okay, since this class is annotated with @service, this will contains all the business logic. Similarly, if user will found or developer found that, okay, this class annotated with @REST controller or @controller, then definitely there must be the endpoint exposed, or there must be the web layer related logic has been written over there. Okay, similarly if he found @repository, then he will easily identify, okay, this is the class where we are doing all the database interaction or all the database operation. That is the reason it's recommended to define different annotation specific to the role. If it is a DAO specific logic, use repository. If it is a web specific logic, use controller or REST controller. If it is just a business logic, use the service. Apart from that, if you have any other logic, let's say you have some external resource to consume, you have some client class, you have some mapper class, then you can easily use the component annotation. Okay, so that is the reason they have provided multiple annotations to just define or specify the role of your class. Now this is what the question, and after immediate interviewer will try to ask you to shuffle the annotation, and he will basically try to confuse you with this annotation. He might ask you, can I define component here? Similarly, in service, can I define repository? In repository, can I use something like controller or REST controller? Can we do that? Can we shuffle the annotation? Absolutely, you can do that, because there is no enforcement from the Spring framework to define the annotation in the correct place, but it is recommended to use. So if I have defined REST controller in the repository class, it does not make any sense. It don't contains any web related logic. So it does not make any sense to define here. But if I'll run the application, it will work. But that is not recommended. Okay. So this is one kind of tricky question. Interviewer will try to confuse you by just shuffling the annotation. Okay, let me revert it back. Fine, we are clear about the stereotype annotation and their purpose. Now let's move to the next one, that is how can you define bean in Spring framework. Okay, so we already understand by defining the stereotype annotation, we can define the bean. We can tell to the Spring Boot or Spring framework, hey, this is my controller class, please create the bean of it. This is my service class, create the bean of it. Similarly, this is my repository class, just create a bean of it. One way, you just define the stereotype annotation to create a bean for you. Okay. In other way, you can define the Java based config. When I say Java based config, it is simple. I don't want to use the stereotype annotation. For example, this service, I don't want to use the stereotype annotation, but I want Spring to create object for me. So how I can do that? By just defining the Java based config. For example, let me define a class here. Okay. Now this is what something of config I have created. I need to annotate here configuration to tell to the Spring Boot or Spring framework, hey, this is what the external configuration I am giving to load the bean. So for that, what you can do, I want to create the bean of this class, right? So just copy the name, go to the config class, public, then what is the class name? Demo service. Fine. To tell to the Spring I want this bean, you can simply annotate here bean. Okay. Now Spring will create the bean for you. He will maintain the entire life cycle of this particular bean. Okay. So there are two ways. Either you can define the stereotype annotation or just go with the Java based config approach, where you just need to play with configuration and bean annotation to just define a bean and to tell to the Spring that okay, this is what the additional configuration I have with me. So you can keep a note of these annotation and their purpose of using. So already I have covered a annotation cheat sheet video in my YouTube channel. So if you need quick brush up on annotation, you can check out that particular video. I will also share the link in video description for your reference. Okay. Now since this is the QA series, I will not much derive into the annotation. I will just go with each and every important concept and their possible interview question. Fine. Now let's move to the next question, that is what is dependency injection? So if you are a Spring or Spring Boot developer and you are attending the interview and you have not faced this question, then it means that interviewer don't have basic knowledge on Spring framework. Without this question, no one can begin the interview session from Spring Boot perspective. Okay, because this dependency injection is something the hot and key feature of the Spring framework. This is the backbone of Spring framework. Okay, we'll derive what is dependency injection, types of dependency injection, when to use which type of dependency injection in details. So first of all, to begin with, what is dependency injection? First of all, dependency injection is a design pattern and it is used to achieve loose coupling between the classes within an application by removing the direct dependency between them. For example, to simplify this statement, let me walk you through one example. Let's say I will go here. Let me close everything. So I have created a package called DI, and you can see couple of classes here. Let me open this order service. Now let's say this order service want to talk to this order repo. Okay, so how he can do that? Forget about that. We have something called Spring framework. Assume without Spring, how we can use the dependency injection, how it is giving us the tight coupling before Spring framework. Okay, we'll understand that. Then it will easy for you to understand. Okay, this is where the Spring came and helps us to make the loose coupling. Fine. Now this order service want to connect to order repository. So what he can do, let's say I have the main method here. I will simply create the object of order repository. Then I can use whatever the method is there, save order, right? This way I can do that. But can you see here the tight coupling, the aggregation we have done here? Order repository, new order repository IMPL. I mean, we are tightly coupling with the class. So tomorrow, if the class name will be changed, you need to refactor your code. Now to make it little bit simple, what we can do, instead of directly use the hard-coded implementation class, we can go with the interface. So if you observe here, this order repository IMPL implements from order repository. Can you see here? So instead of the direct IMPL class, I can partially make it loose coupling by just changing it to the interface. So if you observe, this is what something called runtime polymorphism. Based on the parent reference, we are creating the object of child implementation, isn't it? So this is what something called runtime polymorphism. Now if you observe here, we have partially achieving the loose coupling. So we directly point to the interface. If tomorrow the implementation class is getting changed, I only need to change the implementation class name because the interface is constant here, right? So as many as implementation needed, they can implement from this interface and they can provide their own logic. So I just need to create their object to access that particular business logic, isn't it? But seems this is also having some loose coupling because we are just hard coding the implementation class name here, which you can consider as a partial tight coupling. But again, this is not a good solution to use. Again, to overcome that, what I have done, I have created a factory class who will give me the object of the required bean or object of the required class. So what I can do, see here, I have defined the static order repository who is returning me the implementation class. So what I can do in the order service, instead of using these, what I can do, I will just change here. The class name is order instance factory dot give me the instance. I don't know which implementation instance you will give up the order repository interface, but I need the instance to use it. In this approach, if you observe, we are not taking the object creation header in the main class, but still it is having the tight coupling because inside the factory method, we are telling that okay, this is what the interface and this is what the implementation. But in future they change the implementation. If there are multiple implementation, it's difficult to handle using the factory. It's not difficult. You can check the instance of and get the corresponding implementation object. But again, still here also we are doing the tight coupling. You can consider partial tight coupling, but still the term tight coupling can be associated to this particular approach. Okay, so without the Spring framework, when we are trying to perform the dependency injection, we go with the multiple steps to simplify it. We just try with the implementation class, then we try with the interface, then at the end we try with the factory method or factory implementation, right? But in all the case we understand there is a tight coupling. So we are taking the extra headache of object creation. So rather we create and manage the object creation header. What if someone will do this on behalf of us? That is where the Spring Framework developer bring this key feature called dependency injection, where you just need to tell which bean you want to inject as a dependency in your class by just giving a small annotation. So let me remove this. So in this order service class, who is my dependency which I want to use is order repository, right? So I can simply tell him, hey, Spring Boot or Spring Framework, I want to use this order repository as a dependency. Please inject it. How you will inject it? Just define @auto add. Okay, and since you need to define these classes as a bean, you can annotate your @service. In order repository also you need to define @repository. Okay, it is optional, it's not mandatory to use this annotation, but it's recommended. Fine. So this is what the dependency injection. The dependency bean can be injected by the Spring framework by just defining this annotation. Now going forward, begin from object creation to destruction. The entire life cycle will be managed by Spring framework itself. That is what the dependency injection is all about, and it's a key or hot feature of Spring framework, or you can consider this as a backbone of the Spring framework. Okay, so that's fine about the dependency injection. Now let's move to the next one, that is how many way you can perform dependency injection in Spring or Spring Boot. So we understand what is dependency injection. Now we'll understand how many way we can perform this dependency injection. Okay, so let's go to the code. Now this order repository depend on this order service, or this order repository is the dependency for this order service to inject. Okay, so we understand that is what we can do using dependency injection. Now let's understand how we can perform this dependency injection, or what all approaches available to perform this dependency injection. Okay, so we have done one approach. This is called, let me add a note, field label dependency injection. I will keep a short DI. Now there is also a option to use setter injection, where you just need to define the setter method and you can annotate on top of setter method, which is auto add, and this is called setter injection. Now also there is another approach. You can define a constructor and you can inject the dependency bean over there. So let me define the constructor. Now on top of constructor you can annotate @auto add. So there are three approaches. You can do the field label dependency injection, you can do the setter dependency injection, and you can do the constructor dependency injection. Okay, these are the three approaches. And one thing need to be noted here, if you have only one dependency, order service have dependency order repository, that is the one dependency, then in constructor injection this annotation is not required. If you have multiple dependency, then only you need to define @auto add. If it is a single dependency bean you needed in your class, then it is optional. Okay, so you understand there are three way you can define the dependency injection. Now let's test for at least one. Okay, so let me define a method public void test, something like that, and I need this order repository dot save order. So let me try with the setter. Okay, let's comment out everything. Fine. Now in our class we have only setter dependency injection. Now if I'll go to the main class, now I will get the context from here. Now I will tell to the Spring, hey, from the context please get the bean of which one, order service of type order service dot class. Fine. So make sure it need to follow the camel case, give the proper name. So we'll check whether it is giving the bean to us or not. It will give the service object. Now we'll just simply call service dot test method. Okay, now let me run this. Can you see the statement here? Order repository save order method executed. So if you observe in the order service class, we are just telling to the Spring framework to inject this order repository as a dependency in order service. So that is how we are able to get the object directly. did I create any statement to create the object? No, because I am using the dependency injection feature of Spring Framework, and the type I have followed here, setter dependency injection. Now if you want to verify for the constructor injection, just comment it out, just enable it, just rerun your app. So you can see here we got the result, right? So we can use these three approaches to perform the dependency injection. Just keep a note, we can do field level dependency injection, setter dependency injection, and constructor dependency injection. Now once you answer these three type of dependency injection, now immediately the next question from the interviewer you will get, that is where you would choose to use setter injection over constructor injection and vice versa. It means there are different way to perform the dependency injection. Then at what use case you will go for setter injection, and at what scenario you will go for constructor injection. So you need to explain to the interviewer with the use case or the key points to find out the difference between setter and constructor injection. So this is you can consider as a one of the favorite interview question for Spring developer. Okay, so to understand it, let me walk you through the code. Go to the IntelliJ IDEA. So we have performed all the dependency injection here. So I'll remove these. Just comment these two statements. So we have just enabled the setter dependency injection and constructor dependency injection, right? Now to differentiate these two dependency injection approach, we'll go one by one. First we'll go with the constructor dependency injection. So let me comment this for now. So in constructor, when you will go for this constructor dependency injection, when you want your dependency is mandatory for your bean. For order service, this must need to be injected at runtime. Then you can go for the constructor dependency injection. It ensures that all required dependency are provided at the time of object creation. If any mandatory dependency are missing, the object cannot be created. You will get the error. So the first bullet point here, let me keep a note. Mandatory dependency injection. If you need this use case, then you can go for the constructor injection. So for that, to demonstrate that, what I can do, go to the main class. Okay, let me add the breakpoint here. Fine. Now what I'll do, I'll just run it in the debug mode. Just create the context, pass it. Now it is creating the order service object. We just need to verify, since we inject the repository inside this order service, at runtime it is creating the object of that repository or not, because that is what we inject as a mandatory bean. Fine. So just pass it. Now if I'll expand the service, can you see here? Since we have defined this order repository as a mandatory bean because we have done the constructor injection, at runtime while creating the bean of order service, Spring Framework is creating the bean of this repository. Okay, this makes sense that this constructor injection is used to mandatory dependency injection. Now let's go to the order service and let me stop it. Fine. Now I just want to enable the setter injection. So you understand that, okay, order service, the first point is it is for mandatory dependency injection. Just reverse is setter injection. If you want your dependency is optional for your service or optional for your bean, then you can go for setter injection. Okay, let me keep a note, optional. Let me comment this constructor injection because we just want to test the this particular setter injection. Now here in the setter injection I have defined @auto add, right? Since I just want to prove it that, okay, without injecting this particular bean, it won't impact my service object creation. So that is why I will just comment this. Okay, now I will run it. Application is coming up here. Okay, and we are getting this null pointer exception because we are just invoking the test method, and inside test we are using this particular bean which we are not injecting. Okay, so if you comment it out and if you will rerun it, okay, not here, I'll just comment here. If you will rerun it, your application will come up without any error. Hence it proved that this setter injection is optional. If you don't inject that bean, there is no problem. Okay, so that is the first key difference between constructor and setter dependency injection. Constructor dependency injection is mandatory, where setter dependency injection is optional. Fine, just check the status. Yeah, it came up, right? All good. Now let's move to the next bullet point, that is constructor injection is in immutable nature. So let me add a comment here. Okay, however, setter injection is not immutable nature. Just add a comment here. Fine. So what we understand, this particular constructor injection is in immutable nature. When I say immutable nature, it won't be modified after object creation. Okay, so it will ensure that dependency are immutable after object creation. So let me show you that. Okay, so if you observe in the main class, so when I am creating the order service object, it is by default creating the repository bean for me and injecting for me, because we have just debugged and understand in the constructor dependency injection. In that approach, I don't have any option to modify my repository bean. Okay, so I cannot get the instance of service dot, I cannot get the instance of my constructor dependency bean, I mean which is the repository bean, so I cannot modify it. So if you observe here, I was talking about this, I don't have any option to get this particular bean from the order service. I cannot modify it. That itself is clearly says that okay, this is in immutable nature, because once the object is created, we cannot modify it. Once the object is created for order service, it creates the object of the repository. I cannot modify it. But if you talk about the setter injection, this is the setter injection, right? If I'll go here to the main class, if I'll do service dot set order repository, I can change the dependency whenever I want, which is not giving the sign of immutability. Okay, so since I have the setter method available to inject the dependency at any time, I can do that. It means it clearly says that this particular setter injection is always in non-immutable nature. Okay, so that is what we understand, because we have option to modify it at runtime. So just remove it. That's fine. We are pretty clear about these two statements. Constructor injection is mandatory and immutable in nature. However, setter injection is optional and not immutable in nature. Now the main another bullet point is that if you are using constructor injection, then you cannot resolve the circular dependency. So let me add a comment. Okay, so let me comment this out. If you are using the constructor injection, then you cannot achieve the circular dependency, or you cannot resolve the circular dependency. Now but if you are using the setter injection, circular dependency injection can be removed, or it can be easily mitigate. I will show you how you can do that. Okay, so for now these are the key difference. So what I will do, I will comment everything. Let's say this particular order service, let me comment this as well. Let's say this particular order service want to talk to the another class called this particular REST client service. Okay, so I'll just simply do private REST client service. I'll simply do the, okay, we need to check in the constructor and setter injection, right? So I'll do just constructor injection here. I'll just define @auto add. Then I'll go to this class. This class also want to connect to this order service. See the circular dependency here. Order service want to talk to or want to inject this bean. Okay, similarly this guy, this particular bean also want to inject order service private, and I want to inject using constructor. Can you see here the circular dependency? Order service depends on this REST client service, and REST client service also depends on order service. Now what I'll do, if I'll run the code, let me run it and we'll see whether there is a circular dependency or not. If it is there, then how we can mitigate that. Can you see the statement here? Order service define in file this, and REST client service define in file this. The dependency of some of the bean in the application context form a cycle. Okay, which is nothing the circular dependency. Order service depends on REST client depend on order service. So this is what the problem you will find. If there is a circular dependency, you cannot use the constructor injection. To mitigate that, you must need to use the setter injection. So how you can do that? Now let me just add the setter injection. Similarly, I will go to the order service. I will also remove the setter injection. Okay, this is the constructor injection, right? Just comment it out or just remove it simply. I just want to perform setter injection. Fine. Now, if I'll run this code, still there is a chance to find out a circular dependency. But since we are using the setter injection, I will also tell to the Spring, hey, until unless I will not create the object, don't initiate it. Okay. Similarly, I will do here @lazy annotation. It will do the lazy initialization of your bean. Now, if I'll run the code, there will be no error. Let's see. Let's verify in the console itself. So you can see here application came up without any circular dependency error. So setter injection always helps us to resolve the circular dependency, and by using this @lazy annotation we defer the initialization of order service and REST client service until the first time they are accessed. This breaks the circular dependency during the bean creation. Okay, so this is pretty clear that using the setter injection we can resolve the circular dependency. Using constructor injection we cannot do that. So these are the key points and difference between the setter injection and constructor injection. Now it is up to you how your business requirement or how the way you want to inject your bean in your code. That is up to you what to choose, whether constructor injection and setter injection. So I believe this particular difference with the demo is clear for you. Okay, now let's move to the next one. That is, can you provide an example of real world use case where @post construct is particularly useful? So post construct is an annotation is used to execute the pre-processing logic. When I say pre-processing logic, if you have some piece of code you want to execute an application startup, then you can use this @post construct. If you remember in our last QA video, I have explained that command line interface, right? Command line runner class or interface. So using that command line runner, we can also execute the pre-processing logic. But if you want to play with the annotation, then you can use @post construct. So to demonstrate that, let me go to the IntelliJ IDEA. Then let me remove these annotations and I will simply write a method here, public void, let's say init logic, and I want to write some piece of code here which I want to execute an application startup. So to do that, I need to annotate @post construct. So for now I will just add sysout. Fine. Now if I'll run this piece of code, let's see what will be the output. So this particular method will execute immediately right after the main method of this Spring application class. So this one. Okay. So once it will run this Spring application run method, then immediately it will execute this method. So let's see the output. Can you see here in the output section? First it run the run method of the Spring application class. Then if you will scroll down, you can see the post construct logic executed, right? And if you observe here, we have also used the command line runner. So this command line runner will also execute the pre-processing logic. But if you check the order in the console, first it will run your application run method, then it will run your annotation which is post construct, then it will run the command line runner interface. Okay, can you see here the order of execution? First it will run the Spring application run method, then the first precedence will go to the annotation to execute the pre-processing logic, then again command line runner run method will be executed. Okay, so now if you want to sync this concept to the real world example, then at what use case we can use this annotation, right? So imagine you have a Spring based web application that interact with a database. So you want to use a connection pool to efficiently manage the database connection and to improve the application performance. So in that case, what you can do, you can just write down the connection pool logic over here. Okay, apart from that, also you want to For example, let's say you have the Kafka logic in your code. Okay, let's say Kafka producer and consumer. On application startup itself, you want to initialize your Kafka producer and consumer object, then you can write those logic here. So Kafka producer. Okay, so you can keep the connection pull logic, you can write the Kafka producer and consumer object instantiation logic here. Also, if you want to do some data seeding, when I say data seeding, let's say on application startup you want to populate few data to the DB. Okay, then you can also do that here. Fine. So this kind of pre-processing logic you can keep inside the post construct, or there could be n number of use case you can find while working on the real-time use case. So let's move to the next one. That is, how can we dynamically load values in a Spring Boot application? Okay. So to load any value dynamically, either in a Spring or Spring Boot framework, then you need to use @value annotation. So let me demonstrate this @value annotation. So as you know, by default there are two configuration available in the Spring Boot, that is application.properties file and application.yml file. Okay, so if you define any properties in the properties or YML file, by default it will load by the Spring Boot. So if you want to keep anything dynamic, then you can write it here. So for example, let's say I want to designing some order service where I want to apply the discount. So for that, let's say I want to make the discount value as a dynamic. I have defined something like discount dot offer dot price. You can keep any name as a key, depends on your use case. So I have just defined discount offer price is, let's say, 20. Okay, and I want this particular field to load dynamically, so I can hard code it in the code, but rather than hard coding in the code, better to make it in the centralized place, so that we can write it in the application.properties file or application.yml file. Same thing if I want to define in application.yml file, go to the application.yml. I'll just define discount, then offer price, let's say 25. Okay, so see here I am defining the key and value, and here I am defining in the hierarchy manner. Okay, discount offer price. Now if I want to load this value dynamically, for now let me comment it out. If I want to load this value in my code, what I can do, I'll simply go to the any class and I will define private, which data type is this 20. It could be integer, right? So I can define private int anything, discount price or something like that. Now to load it, I need to annotate @value, then I need to define dollar symbol and the key name from your properties file, that is discount.offer.price. Let's print this value. So I'll just print it here. Okay, let's run the code. So can you see here in the output, the discount price is 20. It means it is able to load from the properties file. Now if I want to load same thing from the application.yml file, let me comment this, just comment it out. Now let me rerun the code. The approach is same, you just need to define the key with @value annotation, discount offer price, that is what the key, right? And that's what I have just defined here. Let's see what is the value. Now it load from, can you see the value? Discount price is 25. It load from the application.yml file. Now again there is another approach. If you don't want to use @value annotation, you can use the class called environment given by the Spring Core framework. So let me define that. Environment, make sure to import it from the org.springframework.code.env. Okay, now we can simply inject this. Let me comment this out for now. Now since you inject it, simply you can call environment dot get the property. Okay, so you are telling to this environment object, hey, get the property for me. He will simply ask, okay, give me the key, I will give you the value. So what is the key? Just paste it here. Just run your code. Can you see here the output load from the YML? Since we comment in the properties, it load from the YML and we saw the value as 25. Okay, so there are two approaches. Either you can use @value annotation, or you can directly use the environment object. Just give the key to environment object, it will return you the value. Okay, apart from that, you can also dynamically configure the key and value on the VM arcs itself. Okay, so you want to start this application in the specific environment, and for that environment you want to set some value, that also you can do that. So go to the interview queue application. I mean, this is the application. Click on edit configuration. Now this is what something you can see the environment variable, right? So let's say here I just want to add spring dot profiles dot active, something like that. Let's say I want to run it from the QA. I have defined this as a key, this part, and this is what the value, and I want to load this environment variable in my application. Okay, so again I can use both the way. I can use @value and I can use environment. So let's try it out. Let's say I will define a field private of type string environment arcs, something like that. You can define n number of arcs. Okay, so I'll define @value. Then I will just define dollar symbol. I just need to define the key. Fine. Now also what I'll do, I'll just use the environment object to load it. So let's say I'll just copy this. I'll just change it environment variable or something like that, and just give the key what you want to load. Fine. Also I just want to print this out the environment variable environment arcs. That is what we are loading using @value. Okay, so I'm just trying to give you the demo that we can use both @value and environment object. So let me run it. Can you see here this particular value load using @value, and this is what we have just provided the statement using the environment object. Okay, so multiple way you can make your configuration dynamic by defining properties file, by defining YML file, by defining in environment variable. Okay, again you can make it more better by centralizing the configuration in any cloud config or external to the application. I'll come to that point. Okay, so that's fine. Let's move to the next one. That is, can you explain the key difference between YML and properties file, and what scenario you might prefer one format over the other? Okay, so if you observe in the code, we understand in Spring application we have both options to use either YML or properties file to load the configuration. That is how we have just loaded now, isn't it? Now what is the difference? Why they have given two different format to just define your configuration? So there are a difference. I will not go with the theory, we'll understand through the code. Okay, so the first difference is syntax and structure. So if you observe in the application.properties file, the way we are defining the key and value using this, right? We are just defining this as a key and we are separating them using the equal, and this is what we are just defining the value. But in YML it uses more human readable and structured format. It uses white space to represent the hierarchy and semicolon to separate the key and value. Can you see here? Let me zoom this for you. We are just giving the semicolon to separate the key from the value. So if you'll compare these two, YML is generally considered more readable and expressive for complex configuration. You can simplify any complex configuration using this YML. Now let's move to the next point, that is hierarchy. So if you'll check in the properties file, it does not follow any hierarchy. In the properties file, it is flat and do not support any hierarchy at all. You have to use the prefix to simulate the hierarchy. For example, when I say hierarchy, for example, let's consider this data source configuration. Okay, so let's consider these four. Let me add enter. Now here we don't have any hierarchy. It is in a flat structure. This is the key, this is the value, this is the key, and this is the value. Can you see here? We are adding the prefix spring.dataSource, then driver class name. This is the again prefix, then URL. This is again prefix, username and password. So we are simulating the hierarchy by just giving a prefix in application.properties file. But same thing, if you'll check in the YML file, let's say let me define these in the hierarchy manner. So I'll go to the here, then I'll just define here Spring data source. See here, I just need to define the attribute driver class name, give the value, then what is that username, then you can define the password. Can you see here the way I have defined the duplicate prefix and the way I have defined the hierarchy in YML? Now it is up to you how you want to compare them. In case of human readability and simplify the complex configuration, I believe this YML is better than the properties file. Can you see here? It took 4 lines and it repeatedly adding the prefix. But here we have the proper hierarchy. So the inbuilt hierarchy feature is given in the application.yml file to simplify the complex configuration with the nested properties. Fine. Let me remove this. Now let's move to the next key point, that is list and arrays. So in application.properties, you cannot define list or arrays kind of configuration. Still you can simulate that by doing the comma separated value. For example, let's say I just want to define my list equal to apple, banana, orange. I can define like that. Okay. I can define complex data structure like list or array using comma separated value. But the inbuilt feature for defining the list and array you can find in the application.yml file. For example, let's say I just want to define my list and I want to define banana, apple, anything you can define. Okay, n number of array and list you can define of any data type. Okay, that is what the another key feature in the application.yml, which is not direct supported in properties. Rather we need to use the comma to simulate this list or array kind of value. Okay, now complex data types, you cannot define complex data type in properties file. It will only understand integer and string, but that you can define in application.yml file. Next, readability. So we just compare the readability in properties and YML file. Properties file are more compact but can become less readable for complex configuration. That is what we just observe in the spring.data source, adding the prefix and doing the configuration. Right? Now, YML file indentation based structure generally makes it more readable for complex configuration, especially when you have a lot of nested properties. Okay, so this statement is itself is clear what is the key difference between the properties file and YML file. Now it is up to you based on your use case whether it contains the simple configuration for your application or you want to design the complex configuration in the hierarchy manner. You need to choose which file format you want, YML or properties file. Now let's move to the next one, that is what is the difference between YML and YAML. Okay, so there are two different type of extension to define the configuration. You can use .yml and you can also use .yaml. So let me go to the idea, then I'll just rename the file. Okay, so let's see, in application.yml file I have defined this. Now I'll just change its extension. We'll find out if there is any changes. If not, then why there are two different extension available. Just rename it, refactor, rename. I will just change it to YAML. Okay, can you see here, is there any changes? No, right? Then why there are two different extension, YML and YAML? So it is very simple, nothing to confuse. Both are the same interpretation and syntax. In older version of Windows, extension restricted to only 3 letters. So that is the reason before people are using .yml, which is the 3 character. Okay. Nowadays there is no operating system level enforcement to have 3 letter in extension. So most of the YML user are using .yaml nowadays. Okay, it's your choice what you need to use. since there is no restriction to keep only 3 character specific to the OS label, you can also use .yaml or yml. Okay, so there is nothing to confuse. Both are following the same interpretation and syntax. Fine. Now let's move to the next one. That is, if I'll configure same values in both properties file and YML file, then which will be load first? Okay, who will load first, either properties or YML file? This is something the tricky interview question. Will not go with the theory. I will directly show you who will load first and how it internally loads. Okay, so let's say I have some common properties in both properties and YML file. So let me remove these things. Okay, or let it be, don't create any issue. So I have this discount offer price which is 25 in application.yml, and same I'm just defining 20 in the properties file. Now we need to see which value will be loaded in the code, whether 20 or 25. Okay, so let's verify it right away. Go to the application. I will just comment it out. Just print here. I'll just change here. Okay, I mean you can load from the environment, that is fine. Better I will not remove this. I will just comment it and I'll just add a new statement. So discount price, I'll directly load using the value annotation. Both the way will get the same output, but let's see. Now we just need to observe whether it will print 20 or 25. If it is 25, it is loading from YML file. If it is a 20, then it is loading from properties file. So run it, then we'll understand the internal who loads first. Let's see the output. Can you see here? Discount price, which is 20. It means the application.properties file is getting more precedence than this YML file. Okay, so in practically or in internally, who is loading first, properties file or YML file? Based on that only you will get this value, right? If application.properties file will load first, then you will get 20. If application.yml will load first, you will get 25. So theoretically we don't know who will load first. I mean we know from the Google, but let's prove it who loads first. So if you remember, in the main class in Spring application run method, I have shown you that it was loading the environment, right? So if I'll open this, if I'll scroll up, this is the place it was loading the environment object. I mean it creating the environment object by loading the properties and YML value. It means this is clear. On application startup, both the file is getting loaded, but who loads first, properties or YML? So to verify that, there is an interface, property source loader. Go to this class. This is the interface. If you will expand its implementation, you will find two. What is them? Properties property source loader, YAML property source loader. What is the extension? Can you see here? YAML. It could be YML, but since there is no restriction, people are starting using YAML. So one for properties file, one for YML file. So let me open this, and there is a method called load. Let me add a breakpoint here. Then we'll see where request is coming first. It is coming to the properties loader or YML loader. That way we can get the proof that okay, who loads first and why we are seeing this value in the console from properties. So go to the interface, go to the YML property source loader. There is a load method you can find. Just add a breakpoint here and in the return. Okay, go here and I will just remove from here. Now what I want to verify, whether property source loader or YML property source loader, who is loading first. So for that very simple statement, I just need to run it in a debug mode. If you observe which class is loaded first, I mean where the request landed first, in the properties property source loader. Can you see here? Let me expand it. Currently we are in this properties property source loader. So we are here now, right? Now let's see directly the result. Now in the property source loader, it load all the configuration from properties file. Can you see here? These are the configuration we have defined. Discount.offer.price, what is the value of it? 20. It clear for you, right? So first it is loading the application.properties file. Hence you are getting the result as a 20. Then if I'll skip this, next request will goes to the YML property source loader. We are in the YML property source loader class. Now let me skip this, and in property source loader we'll verify what value it loads. It loads all the value I have defined in the YML file. Okay, now just skip this, go to the console, and you see the value 20. Now there will be no confusion for you. Now you understand why the value 20 is getting printed here. Why not 25? Because just to observe that application.properties getting more precedence while loading it. So that is the reason that value we can see in the console. After application.properties file, it loads the YML file. So that is the reason that value is not getting override in the first one. This statement is clear for you, right? If someone will ask you who loads first, properties file or YML file, no need to tell him the theory. Just tell that these are the two implementation of this property source loader interface, and just add a breakpoint and give the answer to him that okay, this is how it's getting loaded internally. Fine. Now let's move to the next one, that is how to load external properties in Spring Boot. For example, let's say I don't want to keep the dynamic configuration as part of my code. For example, I don't want to keep any dynamic configuration in application.properties or application.yml file. I want to keep it external to my project. How can I do that? Is this the good practice? Of course, this is the good practice, because if you want to do changes any specific field dynamically, you no need to do the code change, or you no need to do the properties changes from your code and redeploy the code. Rather, you can keep it external, so that any field you are doing the change, do it externally. It won't impact to your code deployment or code rebuild. Okay, so let's say what I will do. So I have just defined a external properties file. Let's say I have just defined something like test.properties. Let me open this, and now if I'll show you here, I have just defined discount offer dot price equal to 35. Okay, so now I want to load this specific property dynamically from external to my application. That is the reason I have just defined test dot properties. Okay, let me close this. Now I need to tell to the Spring Boot, hey, don't look into the application.properties or application.yml file. Rather, you look into the external property file what I am giving it to you. How you can give it to the Spring Boot? You can tell him, hey Spring, the config I want you to import is inside the location. What is the location? It is there, desktop, right? And what is the file name? Test.properties. By defining this, I'm telling to the Spring, hey, load the value from this specific location. And the properties I have defined, file name is this, and what value you want to load, that I have just defined here. This is the key I want you to load, discount.offer.price. Fine. Now let's see. Anyway, we are loading it, right? Let's see the output. Let me rerun it. If you'll see the output, we are getting the value 35. Okay, so this 35 is loading from the external properties, that is test.properties. So by defining this particular field in the application.properties file, just defining this spring config import, you can happily load the external configuration into your application. If any configuration is external to your jar, using this you can provide the path to load that particular file dynamically. Okay, so this is one of the favorite interview question. Now let's move to the next one, that is how to map or bind config properties to the Java object. Okay, so for example, how you can bind all the properties from application.properties or YML file to the Java object. So if you will go here, application.properties, I want this particular for field to be loaded as a Java object. How can I do that? How can I map these four attributes or these four keys as a object in Java? So it's very simple. Okay, let me show you that. Let's say I don't want to follow this key and value, rather I want to create my own object by reading this value. So for that you can simply create a class. Let's say I just want to create a class something like Java class data source. So first step, I need to annotate @configuration. Then next, you need to remember it carefully. Okay. So what is the prefix you can find here? The prefix is spring.data source. In all the four key, you can find this as a prefix. So just copy this prefix name, go to the config class, annotate here @config properties, and tell them, okay, I want to load the key and value whose prefix is this. Now I will just give you the value name or the next key name. Based on that you need to load. So you need to write in such a way. Let's say driver data source is there, right? That is the prefix. Next, what is the part is left? URL, username and password and driver class name. So for that you can simply do, make sure to define the same name whatever is there as a key, as a variable in your class. So let's say I want to define private. Okay, let's say I just want to load only these two fields and I want to convert this particular properties as a object. So I'm loading username and password. Okay, what is the prefix? This. And what is the value I want to fetch? Username and password. So that is the reason I have defined the attribute name is same. Okay, next you need to define @data, all argument constructor. Also you need to define this as a component. Fine. Now to verify whether the properties value is getting mapped to this particular object or not, what I will do, I will go to the main class and simply I will just inject that. Okay, so you just understand how to perform the dependency injection. I want to inject this data source config as a dependency in this main class. So simply I will just do data source config, inject using auto add. This is what I am doing, field label injection. Then I will just simply print here, guys. Okay, now let me run the code. We'll just verify whether these properties is getting mapped as a Java object to this or not, because I am telling him, hey, please load the properties by extracting the prefix, and this is what the next key which you want to load. Let's see whether we are getting the result or not. Okay, so it's giving error. What is that? Parameter 0 of constructor data source config required a bean of. Okay, so we have not defined no argument constructor, right? Just define it. Let's rerun it. Can you see the output? This is what the config value we are loading, right? This value we are loading from properties file to the Java object, and the object which we created is data source config. Okay, so this is the simple example of loading the properties as a Java object in Spring Boot. So for that you need to use the key annotation, that is @configuration properties, and you need to define what value you want to load by just specifying the prefix. So what it does, it will go and based on the prefix it will search in your properties file that he found, okay, spring.data source. Next he will start comparing the value, I mean the next key, username and password. If he found those key as a variable like this username and password, then he will load that, or he will just simply bind those value to this particular variable and it will build the object. Okay, so that's it. So I hope you found it valuable and learned something new today. So if you have any questions, suggestion, then please feel free to leave them in a comment below. We'll meet you again with the part 3 video of the same series. So until next time, keep learning and I'll see you in the next video. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.